companies, because the point of this experiment is to actually find the specific heat capacity of the metal. So I don't know what the metal is, so that is a known metal that I have here, and a thermometer, and scissors, papers and pen, just so that you want to record all your work. Okay, so for this experiment, what you need is the two styrofoam cups that's going to be in starting it, and you take one of the styrofoam cups, and to fit into the other cup, what I'm going to do is cut the edges along. Okay, so let's just do that. Okay, so this is going to be going on top of the other styrofoam cups, like this. Okay, and the purpose of us using a styrofoam cup is to create your calorimeter, just so that your heat is not lost. Okay, and I'm going to take the cup that I cut it on top and poke a hole through on top, just so that I can fit the thermometer. Make sure that the hole isn't too big enough. Okay, you just want a mini hole just so that your thermometer fit just with the calorimeter, because you don't want it to fall right through. Okay, so your calorimeter is pretty much ready, and for the first part of the lab, it tells you to find the mass of the empty calorimeter. So what I'm going to do is take the entire setup and find the mass of it by placing it on a top balance. Make sure you report that. That is your mass of your empty calorimeter, and you take that back. Now I'm going to add hot water to it. So make sure you don't touch your beaker, because obviously it's going to be hot, so you be cautious and use maybe a paper towel or so. Okay, so I just added the hot water. And take the temperature of your hot water that is in the calorimeter, and what I'm going to now do is take the mass of the water that I just added by placing it on a top balance. And yet again, it's going to include the mass of your empty of your calorimeter, as well as the mass of the water. So, but before you add the water, you already found out the mass of empty calorimeter. So using that way by difference, you can find the exact mass of water that you used here. Okay, so make sure that you report your temperature before placing the metal. And yet again, this metal piece has been sitting in room temperature, so obviously the initial temperature of the metal itself is equal to the room temperature. So now I'm going to take the metal and quickly add it to the calorimeter. I'm not opening that way too much. Instead, I quickly added it just so that I'm not losing any heat from here. And what you're going to do is now weigh the entire calorimeter with the water as well as the metal piece in it. And yet again, weighing by difference, find the exact mass of the metal piece that has been used. Okay? Okay, and now I'm going to report the temperature at every 20 seconds or so until I see a stable temperature. Okay? Okay, so pretty much now the temperature has been stabilized, and this is going to be your final temperature for both your water as well as the metal piece. Now that you will have all the information needed, you can use that information to find the C, which is the specific heat capacity of your unknown metal, and using that, match it with your literature reference, and you can find what metal that was, and compare it with the literature value as well. Okay, so thank you for watching. Have fun doing these experiments.